Determine the coordinates of the vertices of a square inscribed in a triangle with the vertices having the coordinates a 0, 0, b 2, 1, c 3, 0, and also one of the sides of the square lies on the side AC of the triangle. Okay, so let's try to understand the problem graphically first. So here we have the coordinate axis, and here we are having a triangle ABC. The coordinates of point A are 0, 0, meaning that A coincides with the origin of the coordinate axis. B has the coordinates 2, 1. C has the coordinates 3, 0. And it's given here that one of the sides of the square lies along AC. So here, let's name the square as P, Q, R, and S. So here, PQ, which is one of the sides of the square, it lies along the side AC of the triangle ABC. Now our goal will be to find out the coordinates of the vertices of the square. Okay, so let us begin. So we'll consider that the length of each side of the rectangle, let it be of alpha units. So that means PQ, QR, RS, and SP, they are of equal length with a value of alpha units. We will also suppose the coordinates of point P. So let us suppose the coordinates of point P is at a, 0. Now if the coordinates of point P is at a, 0, then coordinates of point Q, that's going to be at a plus alpha, 0, 0, because there is no y coordinate here. Now we can also define the coordinates of point S. Now the coordinates of point S, its x coordinate is going to be a, and the y coordinate is going to be 0 plus alpha. So that means it will be a, alpha. And then the coordinates of point R will be the x component will be exactly the same as the x component of Q. So that's going to be a plus alpha, and the y component is going to be simply alpha. So that means our goal will be to find out the value of a and the final value of alpha, and that's going to help us find out the coordinates of the vertex of the square PQRS. So let us begin. So what we'll do first, we will try to find out the equation of the side AB of the triangle ABC by using the 2-point form of a line. So the 2-point form of a line, let me quickly remind you here, is given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. So here x1 y1 and x2 y2 are going to be 2 points through which the line passes. Now since we have the coordinate point A and coordinate point B, we can find out the equation of AB. So here we have y minus y1, so y1 will be 0. This will be equals to, now we need the difference of the y coordinate, so that's y minus 0 divided by the difference of the x coordinate, so that's 2 minus 0. This will get multiplied to x minus x1, so x1 will be 0. So this is going to give us the equation 2y equals to x. Fine. So let's label this as equation number 1. Fine. Next, what we'll do, we'll try to find out the equation of BC. So again, we'll be using the 2-point form to find out the equation of BC. So this time we will suppose that, let's say, B corresponds to x1, y1. And then we have C corresponding to x2, y2. Fine. So we have y minus y1. So y1 will be the y coordinate of point B. So that's 1 equals to, now we need y2 minus y1. So that's going to be 0 minus 1 divided by the difference of the x coordinate. So that's 3 minus 2. This will get multiplied to x minus x1. So x1 here is 2. So solving this equation, we're going to get x plus y equals to 3. So that's the second equation. Now clearly point S lies on the line AB. So that means a alpha, which is the coordinate of point S, is going to satisfy the equation of AB. So let's write it down. Since point S lie on the line AB, so that means S is going to satisfy the equation AB. So we can say that coordinate a alpha will satisfy the equation of the line AB. All we have to do, take the line AB and replace the value of y with the y coordinate, which is alpha. This will be equals to x. So x will be simply a. So we have 2 alpha equals to a. Let this be number 3. Then we have point R. So point R is going to satisfy the equation BC. So we can say point R satisfies the other equation, which is x plus y equals to 3. So here also we can replace the value of x with the x coordinate of R and the value of y with the y coordinate of R. So we have a plus alpha equals to 3. So that gives us a plus 2 alpha equals to 3. That is equation number 4. Now we will use equation 3 and 4 to obtain the values of a and alpha. Now here in equation number 4, what we can do, we can replace the value of a with 2 alpha from equation number 3. So we have 2 alpha plus 2 alpha equals to 3, which gives us alpha equals to 3 over 4. Now that we have the value of alpha, we can also find out the value of a. Then from equation number 3, the value of a is going to be 2 times alpha, or simply 3 times 2. So now we have successfully obtained the value of a as well as alpha. Now we are now ready to find out the coordinates of the vertices of the square. So coordinates of point P will be a comma 0. So that means this will be 3 over 2 comma 0. Then coordinates of point Q. So we need a plus alpha. So we are going to add 3 over 2 with 3 over 4. So that's going to give us 9 over 4 comma 0. Then we need the coordinates of point R. So R is also a plus alpha. So that's going to be 9 over 4. And the y coordinate is alpha. Alpha will correspond to 3 over 4. And finally, we have point S. So point S, the a coordinate value is a. So that's 3 over 2, comma, the y coordinate is alpha. So that will be 3 over 4. So hence, we have successfully obtained the coordinates of the vertices of the square PQRS, which is inscribed within the triangle ABC.